Welcome everyone and thanks for joining our webinar today. Topic is a Minitab statistical software design of experiment. I'm Nur Salawati. I'm the technical support specialist at Bizit Systems. Bizit Systems are independent local presentation for Singapore, Malaysia and Batam, Indonesia. Hopefully in this 1 hour session with me today, you're able to know more about Minitab statistical software. So here we have a housekeeping item notes before we begin. We have a Q&A session after the presentation. Please submit any question you have and we try to our best to answer them if have a time. If no, we will answer afterwards by email. We recommend viewing this webinar on your laptop or PC for the best result. Please fill up our survey before you exit the tab. This survey will help us to improve the quality of all our upcoming webinar. And then for information, we record this webinar and upload to our website www.bizit.com and our YouTube channel, Minitab Malaysia and Singapore. So there's no problem if you miss anything or want to review afterwards. Okay, so Minitab was developed in 1972. So today Minitab in market for 50 years. Minitab statistical software is a software package for statistical analysis. So variety of statistical tools are available in Minitab. This software, it will be powerful statistical software since everyone can use, whether you are statistician or non-statistician, or you are data sciences or non-data sciences. So our flagship product is a Minitab statistical software, and we have 5 others product as well. They are Minitab Connect to transformation and for the dashboard, and then we have a Suffolk predictive modeler for the machine learning and predictive analytic. So, but nowadays, some of the algorithm inside the SPN are available in Minitab statistical software. And then we have the quality trainer. The one is the online training. Consists of few models like statistical inferences, regression, DOE, and so on. And then we have Minitab Engage is a for ideation execution project. And then Minitab Workspace for visual Listo template like VSM, FME, and so on. But today we focus on Minitab statistical software with specific tools. It will be design or experiment. So if let's say you are interested further to know others product, we know we provide on all the product demo on offer for all the product. Okay, so and then Minitab is will use from many various industry. Is a manufacturing itself. I think most of you coming from the manufacturing itself. And then we have a medical device and pharmaceutical customer. We have healthcare customer also. We have the financial services and so on. And then here is some of the tools available in Minitab statistical software. For example, in the quality side, so we have a measurement system analysis, and then after that we go for the how to know or how to monitor our process with using the control chart, and then we have the capability analysis. Okay, so all these measurement system analysis, control chart, and capability analysis, we already have a webinar on that. So we share the link for you. For those are not available to watch, to join our previous webinar regarding the measurement system analysis. We have a control chart, and then we have the capability analysis. So I will share this link on the chat box. Okay. And then we have other tools available for the reliability engineering. And then for your information, Minitab 21 have a new tools for the reliability. We have a corp regression. Okay, and then also we have today session is focused on this one for the DOE, design one experiment. So if let's say you already know about your measurement is a good, after your measurement is a good, you go for the monitoring or stability process. Your process is a good one, and then you go measure for the capability. So once your process is capable on that thing, maybe you want to see on the optimization. So the one best tools to do that kind or to want to see the optimization, so it will be design of experiment. So but today we not only cover all the 6 design, we focus on the full factory design. Okay, and then we have also others thing like business analytic is something like you doesn't have any requirement to do the experimental, but you want to do the prediction. So we are able to have something like statistical modeling, like regression itself. We have the time series itself. We have the multivariate of analysis, something like one. And then we just added, starting with Minitab 19, we have the, we call it classification and regression tree. Okay. And then we have the process validation, but just I want to highlight here, okay, that one, this tools is not like in this sequence. It will be from different menu. Okay, and then here is the, since in the statistical software, we have a complete tools for analysis. So our customer is coming from various industry. Okay, and then the other type of a company is maybe can be a multinational company or can be from the small SME company, also fit to use this software if your aim to be a data-driven company. So today agenda is related with the, I think it's the most popular tools normally used by our customer. It will be design of experiment. So we try today demo start from the how to create design itself from the Minitab. Not only start with the analyze, you can create your design itself, and then after that you analyze your experimental using the statistical tools like ANOVA, regression, and so on. And then after that, we go for the optimization. We have a response optimizer. And then after that, we try with the simple snap of the less step to run the design of experiment using the assistant. I think if let's say you are all user of this Minitab, I think you already know about the assistant. Okay. So hopefully in 1 hour sharing, today we are able to see how DOE works, and maybe DOE will be one of the tools to solve your problem. Okay, so the design experiment is a series. Okay, it's a series of run or tests in which purposely change are made to the input variables at the same time and observe the response. Maybe before this in secondary school, we already do the experimental. If let's say we took the science subject or something, then one we already do the experimental. But we mostly we do like something try and error. So we just do on only one time, 10 time, and so on. But in the if you say you're using the experiment, design of experiment, they will come up with the, we call it design experiment, to know how many runs you should do, and then how many repetition you need to do, and so on. So that one in the design experiment, we call that one is a series of runs. Okay, not only one, maybe it's a combination of all the your factor and then your level in at the same time. Okay, And then in industry, maybe design assessment can be used to systematically investigate the process or product variables that affected the product quality. So for example, just now I mentioned that after you define the process condition like stability and capable, and then you can improve to enhance the quality and so on. So DOE here maybe in the real life after your process is stable and then capable, and then after that you do the DOE. But DOE can be without know about the stability and then without know about the capability, but you might be have some others problem. Okay, you will facilitate, and then maybe after that you can conclude that DOE is not good way. So DOE is something like systematically project or systematically start to run or to do the DOE. So will we use DOE to maybe determine which factor has significant effect on the response itself? Maybe you have something like you want to identify the effect of the interaction between two variables, and then you want to optimize the process performance itself, and then you want to reduce development time for the new product. Okay, and then you can reduce the variation in the process itself, and then of course you want to determine the optimal setting of the factor that optimize all the response. Okay, maybe this one is one of that you will be reduce your cost and so on. Okay. Okay, for those are new with the design of experiment itself, here's some important terminology to know before we go further. The first thing is a response, is an outcome, or come to the mathematical, we call it is a why. Is the aspect of measurement are you interested in improving? Okay, so the term word is here is to improving, or something like for this case, we want to know about the time of boiling. Okay, the critical part. But in terms of you in the company, maybe you can go further with the critical to quality. What kind of the problem you face it? Okay, of course you want to increase your satisfaction of your customer or something that one, but you need to convert them into the will be our measurement. And then another term is we call it factor, or sometimes we call it variable, or sometimes maybe you will use the parameter. Okay, things which you actively change to influence the outcome. And then another thing is the level. We call it the setting of each factor in the study. For example, here we have a factor of variables is a type of pot, we have electrical heat, and then we have the lead. So this one is considered the parameter. If let's say your type of the pot itself, something like glass or metal, we consider that one is the level. Okay, for example, also you want to do the something like baking cake, something that one. So and then you go for at the supermarket, you can see a lot of brand and a lot of type of flour itself, high protein, and then we have the flour normally high gluten and so on. We have a lot of type of the factor itself. So that's why you want to see which one is the good one. Okay, so that one is you set up the level. We call it the level. Can be 2, can be more than 2, can be 3, and so on. Okay, but if let's say you have more than 2, maybe it will be complex for this case. And then we have the experiment example. For this case, I want to know about the boiling water. And then our response or our outcome is the time of boiling. Maybe it's a boiling water. Maybe you want to know about the structure or the atom itself, H2O, something like a percentage and so on. Maybe you can further for this case, but for me, I want to just only know about the time of boiling. Maybe I rushing, I just want to have 10 minutes only to prepare all that thing. So I want to less that kind of the number. So that's why maybe I need to do the experiment like type of pot I need to using, and then I need to look on the electrical heat. Maybe I just need to use already for the height level, and then I need to have a lead pot. So something that one we will try and error. So we not only look on one side, maybe it can be more than two factor, more than two level. But for, of course, we start with the two level. Okay, maybe secondary school experimental, we just know about the type of pot only without setting the level. But now you in the process itself, you realize you want to see more on the level itself. You already know about the factor, but which level, what level you is want to see on this one. So hopefully you will get some terminology here. If let's say I say that about the parameter, how many parameter you have, and then how many level you have for each parameter. So of course cannot must be like same level, no. If let's say this parameter is a 2 level, and then we have a second parameter you set up for the 3 level, so we have for kind of the design itself. Okay, not we call it the factorial. Maybe we add this name for the, we call it the mixture design. So more complex on this one. Okay. So let we go. So if let's say you want to more about the success story about the DOE, our customer was already run or implement in their company. So you are able to see in this our case study. Okay, so I will share the links how to get it. How you can get the okay, I will paste this link to the chat box. Okay. So you may able after this, if let's say you have a time, so you can see the other successful story about the Minitab app, and then about the specific about the DOE itself. So DOE is not only for MNC company, as SME company also can do the Minitab. Okay, so if let's say you have a challenge or you have problem like want to identify the fixed manufacturing process, something that one from the fault itself, or maybe you want to optimize a new in-house electro polishing process, or you want to analyze the effect of the key process factor to improve the manufacturing process. So all this kind of the problem you face it, maybe you will be proceed with the DOE. Okay. So here is some guidelines to run the DOE. Okay, of course, this the first 3 steps here is that you define the project, and then you choose the factor and the level, and then you determine the process, the response, and how to measure it. So all these 3 steps, I think most of you already know. Okay, if let's say you go for the SPC part, also you need to have the problem, so problem statement and so on. So after the differences between the others project with this DOE, as we call it, this one is experimental design. Okay, so to decide which type of this experimental design you need to use, it will depend on how many factors you decide and how many level you decide. Of course, it will be related with your costing and your time. Okay, and then after you decide what type of design you should do, okay, and then now you know how many design you must run. Okay, for example, you have a 2 factor, 2 level, so 2 power of 2, which is a 4 run. Okay, 2 power of 2 is a 4 run. So 4 run, only 1 replicate. If let's say you want to more accurate, maybe you can go for the 3 replication. So 4 times with the 3. So need to run about the 12 run experiment. So maybe one experiment, it will cost how many, and then how many duration you need to take for one run. So from here, okay, from the experimental design, you will know how many run you need to run and so on. It will depend on how many factor you decide, how many level you decide. After that, you can run the analysis based on the design itself. And then after that, you can proceed with the others, with the statistical analysis like ANOVA, like regression, and then maybe you can go to visualize something like using the factorial plot, a cube plot, and so on. So you have to confirm the result, and then you will use it, and then you will make it a recommendation from your design process. So design experiment is something like, it's not stop after finish you stop. No, it's something like continuity. So that's why DOE will be on one of the tools inside the continuity project or improvement project. Okay, so it will be you have a new problem, so it can be like this one, like that. And then you have coming with the new problem, you can build it like the best. And then the I'm not sure you are familiar or not, this one. So I will show in the Minitab. So if let's say you open the Minitab, actually the Minitab will show for you. So you can go for the stat, go for the DOE, and then you can see the factorial, for example. Okay, you can see the create. You must create the design first. And then in the gray here, so you can see that you cannot, okay, Minitab will give you some idea. So meaning that you need to finish the create the design first before you can further for analyze, you can further for predict, you can further for response optimizer. So if let's say we look back on this one, so this will be the same. Okay, so you are able to see this guideline in the Minitab statistical software. Okay, so Minitab offer the following design experiment. For example, it's a screening design. We have the factorial design. We have the response surface design. We have mixture design. We have the Taguchi design. But today I will focus on the factorial design. For your information, screening design may be for the starting with the experimental. You have a lot type of the factor. Maybe more than 10 factor you have. So you might be go for the screening design. After you screen the design, maybe only have five factor with the 2 level. Maybe you can go for the factorial design. So inside the factorial design, we have full factorial design, we have fractional factorial design, and so on. But if let's say your response itself has something like curvature, it's something not straight line, so you can go for the response surface design. So if let's say your design, your factor have the mixed level, and then you can go for the mixed design. Maybe you will look on the loss function, something that one is you consider the noisy on your experimental, maybe you can go for the Taguchi design. So this one is available in Minitab. So how to get it? How to get this one? So you could go for the stat, go for DOE. Okay, so you can see that screening side, we have the factorial, we have the response surface, we have the mixture, and then we have the Taguchi. So for those are new with the Minitab, starting with the Minitab 90, Minitab already have put another way, we call it the analyze binary response. So for your information, your response can be categorical, or can be binary, something like yes or no, something that one. The text can be for the response, not only the measurement like measuring like weight, height, and so on. So maybe you can have something like accept or reject, because we have a analyzed binary response for this case. Okay. So what is mean by factorial design? So factorial design allow to simultaneously study of the effect of several factors and on a process. So varying level of the factor simultaneously rather than individually. So in the factorial design itself, we combine all the level we look for example, is a temperature. Okay, we have a temperature 20, we have temperature 40, something like one. And then you combine in this one trial. Okay, we can have a temperature with the 20, and then the duration of time maybe can be at 10 minutes. Okay, next experimental, next trial, maybe temperature can be 40, and then the time or duration can be 20, something like what is a combination. And then for your information, factorial design is to efficiently estimate the effect of each factor on the response itself, estimate the effect of interaction between the two or more factor, and then test the curvature in the response by including the center point in the design. This one is something like a height. Okay, it's a curvature. It's not only straight line, maybe cubic or maybe quadratic and so on. Okay, it's more technically. So for the factorial design, we have a design type, something like we call it, if let's say you see or you Google, it's a full factorial design. Okay, so it can be in factorial design. Okay, and then we have a fractional factorial design, and then we have split plot, and we have Burman, and then we have general full factorial. So in Minitab, they will give it you guideline. If let's say you measure all the combination, and then the number of your factor is 2 up to 15, so you can go for the 2-level factorial. Okay, if let's say you have not the 2-level factorial, maybe you can go for directly to the general full factorial. If let's say you want to see on the half factorial, okay, half factorial, so you can go for the fractional factorial. So I will show. So you go back to the Minitab. Okay, go back to the Minitab, you go for the step, you go for the DOE factorial design. So you click the create factorial design. So in here, we have a type of the factorial design. Okay, so you must clear part, is it, for the design itself. Design experimental design in Minitab, we have a 5. Okay, design experimental in the factorial design, we have type of design. We have 2-level, we have a 2-level factorial, we have 2-level split plot, we have bucket Burman, we have the general full factorial design. Okay, and then we go back to this one. Okay, so this one is a 5 reason why the factorial experiment we use. Okay, the factorial and fractional design are most cost efficiency. Okay, and then factorial design estimate the interaction between input variables and every output others input variables, so we can know about the interaction. And then factorial design are orthogonal design, it's a balanced one. And then for the factorial design, encourage to comprehensive approach to problem solving. And then we have a 2-level factorial, provide the excellent foundation for a variety of follow-up experiment. So most of the beginner, okay, most of the researcher, we start with the 2-level factorial design before we go further for complex one like Teguchi and so on. Okay. So we try with this one case study here. A manufacturing of packet cake mix must determine and recommended baking time and the temperature to print on the back on the box. Okay, so for this case, for the food scientists replicate a full factorial design twice. So mean that they provide 2 factor. It's a baking time and temperature, and then they want to use 2 replication, and then they bake all the cake with a single day, so they consider that is a no blocking. Okay, and then they bake the cake for 30 minutes and 50 minutes. Okay, so baking time here they provide 2 level. First is a 30 minutes, and then second one maybe high level will be 50 minutes. And then the temperature here at the 325 Fahrenheit and 375 pair height. And then the scientists calculate the moisture content by measuring the mass of the material before, after baking. So they will measure the Y, your response is a moisture. Okay, so for this case, we have a 2 factor with the 2 level. Okay, so every factor have the same number of level, if we call it the 2. So for this case, maybe we call it 2, 2, or we call it with the full factorial design with the 2 replication. So how to create the design itself? So we'll go back to the Minitab. Okay, we go back to the Minitab. So for this case, we have a 2 level factorial. Okay, and then our factor is a 2 up to 15. So maybe you can go for the display available design. So you can see here, if let's say you have a factor, 2 factor, you choose the full factorial. So mean that your run will be 4 run. Okay, this one is a without replication. We just only one replicate for this design. And then after that, you can see the factor 3. Okay, you want to see the 3 resolution, and then you go for the 4 run only. But if let's say you want to see more, okay, you can go for the full. So means to say that it's a 2 power of 3. So how many run you should do is at least 8 run. If let's say you see the 8 run is the most costly, maybe you can go for the third resolution. It's only consists of the 4 run, so and so on. So you can see that we have a full factorial, we have the third solution, and so on. So it will depends on you how many what type of design you want. For this case, I will try with the full factorial and then click OK. So I mean that every time without replication, you must run 4 trial and then go for the design itself. So full factorial with the 4 run, resolution full, and then this one is a 2 power of 2, 2 level, 2 factor. So for this case, no center point or block, and then the number of replicate is a 2. And then the number of lot is a 0 because they just consider only one day. Okay, and then click OK. Maybe you have something like today you do 5 replicate, another day another replicate. So maybe you consider that is have a block. Okay, and then you click OK. After that, you can go for the factor. For this case, maybe factor A is a baking time. Okay, baking time. And then the type of this one, the T is measurement. Okay, so if let's say categorical, can be categorical. Okay, and here is the 10 minutes. Here is 15 minutes. Okay, so here is the temperature. Okay, so here is the lower level is a 3 to 5. Height level is a 3.75. Okay, and then you click OK. So if let's say you have more than, so you can set more than, and you click OK. So now they will appear, we call it, this one is a design. So how to read it, how to prepare it. So the first trial here, the first run here, your combination should be baking time 30 minutes and then your temperature 3 to 5. So your Y here is the moisture, how many? Okay, before and after. Okay, you get the value here. For example, it's 50, something like one lah. And then the second run, you should be is combination this baking time at 30 and then temperature at 735. So we will do the second run and so on. So because this one is have a 2 replicate, that's why you have a 8 order. This one is standard order. This one is a run order. So the standard order is a randomized. Okay, Minitab will randomize. If let's say you don't want, you can go back to this one, and then you can go for the factor. Okay, then not randomized. Sorry. Okay, so this one, you unclick here. If let's say you want the one is randomized. Okay, so you unclick here, click OK, and then click OK. So you will get the same. If let's say you not click and not proceed with the default setting, so you will see the run order and the standard order will be the same. Okay, if let's say you choose the randomized, so standard order and the run order will different. Okay, so Minitab will randomize for you for this case. Okay, so this one is how to create the design before you run the analysis, before you run the experiment. Okay, so after you finish all this, okay, you already get the response. So you can proceed with this DOE factorial design. You can see now you able to click on this one. Since Minitab already have the design, so must be start with the define or create the design. If let's say you already create the design in Excel or something like one, and then you put in this Minitab, so you're able to see like this one. So go for the DOE, you go for the factorial, define your custom factorial design. If let's say you doesn't have any experiment, so you can go for the stat, DOE, go for the factorial, create. If let's say you already have, you want to do analyze only, so you choose the define custom factorial. Same go for the others design, the same step. Okay. So we'll go back to this one. Okay, so we try analyze for this case. Okay, so manufacturer of packet cake mix must determine the recommended baking time and the temperature to the print on the box. They want to find the factor setting that result in mean menstrual content about the 26 plus minus 1%. So they must stick baking time is 30 or 50. And then the temperature is 3 to 5 or 7 to 5. Want to do that one. So we proceed with this case study with the analyze factorial design. Okay, so I will go back to the Minitab. Okay, you go back to the Minitab. Okay, so I will open this one. So you now, your mind, you already run the experiment and then you already have your response is the moisture. For this case, they will measure the moisture with the before and after. Okay, after minus before, they will get the moisture of the cake itself. Okay, so how many run? They run 8 run. They were coming from 2 replication. So how to proceed with the analysis? Go back to the stat, go for the DOE, go for the factorial design. You choose factorial design. Okay, but if let's say your Y is start measurement, you can choose the DOE, factorial design, you choose binary response. Okay, so if let's say your Y is a more than 2, okay, you can go for the DOE, factorial design, you choose variability. Maybe you not only measure on the moisture, maybe you measure on what type of that one is a weight, maybe something like one, and so on. So they will be analyzed variability. So we have a different response measurement you look on this one. For this case, we try with this DOE, factorial design, we choose the factorial design. For this case, our response is the moisture. So you go for the moisture. And then the terms here, you will look on the what? For this case, we will look on the temperature, we look on the time, and then we look on also on interaction. So that's why we do the DOE. We choose the factorial design. For factorial design, we want to see on the interaction. Click OK. And then, of course, this one is a statistical. So statistical tools. So you must be a assumption on that. So you click on the for each one, click OK, and then you click OK. Now you will get the result on this one. I will go to stat, go to DOE, go to factorial. You can see on the analyze factorial. So you must decide your response, your terms here, and then you click your graph, and then you click OK, and then you click OK. So you will get the result for this case. On this one, of course, we want to see on the which one is a baking time or temperature. It will most impact to the moisture itself. So maybe you can go for the Pareto chart. So based on this Pareto chart, all the factor and then include the interaction, it will be significant to the moisture itself. Okay, so from here, okay, both of the term is a significant interaction, but significant. So that's why you need look on the analyze. Okay. ANOVA here. So maybe this one is a visualize. Okay, you will confirm it with this ANOVA. So based on this ANOVA, you look on the p-value. So you can see the p-value is less than 0.05. So meaning to say that temperature is significant, time also significant. Interaction between them also significant. But you remember back, in the temperature, you have a 2 level, which is a 30 minutes and 50 minutes. And then for the time, for the time you have 30 and 50. And then the temperature you have a 325 Fahrenheit and the 375 Fahrenheit. So which one is most important level for temperature, most important level for the time? So we go further with this. Next one, go back to the DOE, go back to factorial design. So you can go for the factorial plot. Okay, so now time, temperature, interaction is important. So you go to the factorial plot. And then you can see that this one is this time. Okay, and then temperature, and then you click OK. So you will get the most impact, most effect of the temperature and most effect for the time. So based on this, okay, you can see that the highest value of the moisture is at the temperature at the lower temperature. Okay, the most higher of the moisture is at the low level time. Okay, less time will highest the moisture. So less temperature will be get the higher moisture. So we have the main plot here to see, to give it to you which level for each time. And then you can go for the interaction here also. So based on this one, they will have an interaction between them. Okay, between the temperature and the time. Okay, so after that, we can go for another way. Maybe you can go for the design experiment, factorial. Maybe you can go for the cube plot. Okay, cube plot for this case. Maybe you're a fitted one, and then you click OK. So you will show or visualize your finding with the cube plot here. So with this 50 time minutes, this one is the moisture. This one is the temperature 325, 375. So all this one, I will go back to this. Okay, already done it. Yes, this one. And then we look on the model summary. Okay, so you are squared here. So it's a good one. Okay, more than 70. And then you verify the model itself. Okay, so since this one is the statistical tool, so you cannot avoid this thing. Okay, to rely on to validate your result. So must be look on the normal distribute, must be look on the constant variation, and then the random over. So all this one is a good one. Okay, and then you can proceed with the, just now I will show the interaction plot. Okay, so the interaction plot show that the effect of changing the bake time depends on the temperature. So if let's say here, you can see that, okay, it's something like differences. Okay, so when temperature is high, okay, and your time is low, okay, so will lower rather than temperature low, okay, the time is higher. Okay, so at the 30 minutes, the higher temperature has the much less moisture than the lowest temperature. But at the 50 minutes, the differences in between them is smaller, that one. So this one. Okay, and then after that, maybe you can go for the cube plot. Just now I will show how to get it. This one, and then of course this one, the last aim of this project. Maybe you want to, how about the many design experiment, determine the optimal factor setting that produce the best value for a response of interest. For this case, of course, we want to know about the moisture. Okay, the response itself use the most recent model fit to calculate a solution based on the disability criteria. A response can be minimized, maximized, or aimed at a target. So just want to highlight, since this case study, this case study already good, is a good model. Okay, so if let's say you go back to this one, it's good model. Okay, it's good model with this R squared, and then the assumption also the fulfill. So you no need to refit the model. If let's say your experimental is not so good, maybe you reduce the number of factor, reduce of number of interaction. So you might be refit the model back. So go back to the DOE, go back to the factorial, go back to the factor analyze, you go loose on this one. So make sure only significant factor be available on this selected terms. Okay, so that one, since this case study is only two, okay, it's only two factor, so maybe it's not so complicated. Okay, maybe after this you run your own project like five factorial. So it's something like it's a complicated one. Okay, not only two replicate, maybe more than two, more than three replication. So it's more complicated. Maybe you cannot be a straight way like this one. So you need to refit the models before you go back to this DOE, optimize them. Okay, so response optimizer, this one. Okay, so before that one, Minitab will we trigger the last part of the model. Okay, you refit, and then Minitab will consider on the response optimizer. Once you create the optimizer, Minitab will trigger the last part of this. Okay, in the response optimizer. So you will be care about this one, beware about this. So you refit the model, you change the model, and then you make it clear what is the best model, and then after that you can go for the response optimizer, this one. Okay, so for this case we try with the target itself. We have a target, your maybe your spec meet the target, and then the lowest the enter, and this one. So I go to the Minitab. Okay, go back to the Minitab. Okay, so go for the stack, go for DOE, response, and then I will choose the response optimizer. For this case, we won't have a target. Okay, so our target is 26. The setup here. Okay, so it's the lowest. The slowest. Sorry. Okay, and then your option here. Okay, your temperature, your constraint here, hold at the light or something like one. Just we proceed with this one only, and then maybe you will go for the result. Okay, and then you go for the graph itself. Then you click OK. Okay, so your objective is on the target. Okay, on the target with this target. Okay, and then here is your feed. Okay, feed, and then this one is your response. This is setting here, and then you will get the optimize this one. So actually you can okay, you can set it up for this case. Okay, the highest, lowest, something like one. So this lowest, okay, you can manipulate for this case. Okay, double click and then you click on this one. Okay, so I will go back to this dialog box. Your target, maybe you set up here. Okay, the lowest maybe here is 25. Okay, the upper here maybe it's 27, and then you click OK. So you click OK. So you will get this setting. Okay, so you will get this one, the fit between this one, this setting. Okay, the best thing, if let's say you want to target the moist, is that your temperature is 375 and your time is between 30.5897. So this one, it will be print on the box. Okay, so this one is how you want to use the DOE to solve your problem. The first, we create the design. After we create design, we run the analysis. During the analysis, you will get what factor is a significant and what level is most important. After that, you will try to optimize your setting. Okay, and then you get the setting for each the variable itself. Okay, so proceed with this one. So we have another way to get the DOE in the Minitab. So we can use the assistant, but the assistant, we have a limitation on that. If let's say you have a more than 5 factor, so you're not able to use the assistant, DOE in assistant. So you need to back to the DOE in the step menu. Okay, so that's why I always suggest you try with the step menu first, and then if let's say just only reconfirm, just only to study, so you might be use the assistant menu. Okay, so it will works like the same. Okay, it will works like the same. So you can go for the assistant. Okay, you can go for the assistant. You can see the DOE, and then you can see that there's plan and create. So whatever we do, we need to create the design first as a previous one in the step menu. Also, you need to create the design first, and then after you create, okay, for example here, after you create, okay, so for first case is a A, okay, this one is a B, name for the factor, 6 factor, because here we use the 6 factor, C, okay. Okay, and then here maybe 1, sorry, here maybe -1, okay, -1, here is a 1, -1. Okay, so your response, so how many run is the 12 run, and then you click OK. Okay, so now you're using the screening model and then your response. So after you have the first run here is a factor A is a -1, factor B is a 1, C1, D1, E, -1, F1. So this combination, what measurement you will get. So for example, it's 57 and so on. So after finish all this, you come back to the assistant, and then you can go for the DOE. You can see the analyze and interpret. Okay, you can see the analyze and interpret for this case. Okay, for this example, I have the screening, right? So go back to this one. Okay, for the create itself, they will the same. Will we have a summary report? They will have a report card. So in the summary report, they will use what the design information, how many factor you have, how many run you have, and then the setting factor here, and then this one is the effectiveness of your number of run. Okay, and then here is the moderate, small, large. They will give it you. This is randomized, and then the next step, they will show you the next step. What is the next step? So you need to run, complete all the free experiment activity, and then run your experiment. And then after that, you can go for the analyze here. Okay, back to the DOE, analyze and interpret. Once you already done for this case. Okay, so maybe it's not satisfied, you can go evaluate for this factor. Okay, so not only understand menu, but you will use the DOE using the assistant. Okay, but for the assistant have a limitation on that, only 5 factor for the full factorial. Okay, if let's say you go for this case, plan and direct here is a plan. Okay, create design itself. So they will assistant already put here optimize only 2 to 5 factorial. Okay, so if let's say for the screening part, they only up to 6. Okay, we start up to 1 5 factor. So this one is a limitation. If let's say you have more than that, so you can go for the stat DOE. So go for the maybe factorial, maybe screening factorial, maybe the response factorial, and mixture design and then the Gucci design. Okay, so I will back to this one till finish all this. Okay, so do you have any question? So if let's say have a question, let me know. Sorry. Okay, I will share this material. So you put your email in the chat box or Q&A box. I think it's a chat box. So I will email after this. Okay, so this one is a good question. It's a which is a DOE is better to use for parameter optimizer, full factorial or response surface factorial. Okay, response surface. So this one is a depends on your situation. Okay, depends on your factor, depends on your response itself. Okay, it's not this case is not will be the good one, is something that one no, it will depends on your situation, it will depends on your factor, it will depend on your level, and then of course it will depends on your costing. So that's why we have a lot type of the design itself. Okay, today I will just show on the design, full factor design. So you come back to the stat DOE, maybe you can go for the screening part first, and then after the screen part 5, you go for the factorial. Okay, but your about the limitation, maybe you can go for the response, you can go for the fractional only, and then maybe if let's say your y is not the straight line, maybe the response surface it will be the best way. Okay, for sure, I think the real life one, I think most of you will use the response surface design. Okay, which is the best is depend. Okay, hopefully answer your question. Okay, so we have this question. Oh, okay, so good question also. Can the response be 2 level, only delicious or not delicious, and not a measurement? Yes, can. They will have that one in Minitab. Let's say you have the y is a not measurement, is a something like text. You can go back to the stat ANOVA. For DOE, you can go for the factorial design, and then you just binary response. If let's say you have a 2 option only, delicious or not delicious, so maybe it will be different in term the it will different in term the ANOVA here. Okay, and then the regression line here. Okay, we not use the regression, maybe we'll use the logistic regression, something that one, just different methodology, method only. The objective is the same. Okay, hopefully answer your question. If the response is defective percentage, how to perform defective percentage means meaning that it's a measurement, is it? Okay, so if let's say measurement is still will the same, go for the DOE factorial design if measurement, and then is your response is something like accept, reject, yes or no, okay, delicious, not delicious. So this one is a co-booster binary response. So that's why the first terminology I always show is you need to make it clear about the response itself. Okay, I think it can be a measurement. Of hope answer your question.